Hello everybody. We're going to take a look at multiplying fractions with reducing at the end. And I'm looking at, this is Unit 2.3b at WAMAP. And we've got a couple of problems here. 1/6 times 2/5. And they always say to reduce these to lowest terms. And in the first set we didn't have to reduce because they didn't have factors in common. But these sets have factors in common, so we will have to reduce. Multiply 1/16 times 4/5. So let's take a look at those two problems on my tablet. All right, so in the past we've set up multiplication problems with fractions by expanding out elements. So if we were to do the same thing here, we could say 1 times 2. And then 6 we can break down to 2 times 3. And 5 is a prime number, so we can't do anything with that. But we can write this as 2 times 3 times 5, right? So we define an equivalent to 6, and then we take the 5, and we multiply these together. And the reason we do this is that, when we were playing Go Fish, if there's a 2 in the top, you can go fish and take a 2 out of the bottom. And when you have only prime numbers in the numerator and denominator, and of course we don't count 1 as prime, but it doesn't have any effect on, there's no change. These two cancel out to make each other 1, so we have 1 times 1 here, and then 1 times 3 times 5. So we're going to have 1, and then we have 1 times 3, which is 3 times 5, that's 15. 1/15. So this would be our pre-reduced answer. If you're going to do this the standard way, 1 times 2 is 2. Let's do that right here. 1 times 2 is 2, and 6 times 5 is 30. So what we have done now is just multiplied the fractions without any pre-reduction, right? So we didn't take out any common factors, so now we have to look for them. And you can go either way. 2 over 30, we know these two numbers are both even, so they can both be divided by 2. So let's start by taking out a 2. And we'll get 1 over 15. And then 1 only has one factor, and 15 has 3 and 5. So they don't have factors in common. So this is also a unit fraction, so it can't be reduced any further, right? You've got the smallest number possible on top. Okay, let's look at the next problem. 1/16 times 4/5. Same deal. If we do just straight across multiplication, we've got the number of pieces times the number of pieces. That's the numerators. 1 times 4 is 4. And that is over the size, 1/16 times 1/5. The size over here, 1/5. So we multiply those two together. 5 times 16. And if you remember my multiplication by 5 rule, you take half of 16, which is 8, and add a 0. So we have 4/80ths. And then we have to divide out whatever we can find. It looks like these both might be divisible by 4. So let's take out a 4. 4 divided by 4 is 1, and 80 divided by 4 is 20. So that's going to be our answer. So over here on this side, if you had wanted to define 4 as 2 times 2 and define 16 as 2 times 2 times 2 times 2, then we could have written out the fraction a slightly different way. When we multiplied them together, we could have gotten rid of 1, 2 here, 1, 2 here, 1, 2 here, 1, 2 here, and then we would have just had, do we have any more? That leaves 1 in the top, and then 2 times 2 times 5. Oops, this thing turned into an eraser. Times 5. So we would have had 2 times 2 times 5 with just the 1 on the top. And 2 times 2 is 4, times 5 is 20, so we would have ended up with 1 over 20. Same as over here. So it's kind of, if you pre-reduce, it can save you some work. And once you get used to it, it works really well. Otherwise, you can just multiply the number of pieces times the number of pieces, and then the size times the size, and you'll end up with a total that if these can be reduced, 4 can break down to 2 times 2. Oops. I can't talk and chew gum at the same time. 2 times 2, right? And then 80 can be broken down into 2 and 40, and 2 and 20, and 2 and 10, and 2 and 5. And then we have all of our numbers we need. And if we want, from here we could say, okay, get rid of 1, 2, get rid of another 2. So now there's just 1 in the top, and then we have 2 times 2 times 5, which is 20. Okay? Does that make sense? I hope so. Go give those a try and try a few different ones, see how you do. And if you have any problem, let me know. Oh, why don't we plug these in at WAMAP and see how we did. So the first one, 115. 1/15. About an hour ago I got one wrong because I didn't reduce. And then 1/20. These are called unit fractions when they have 1 in the numerator, so those can't be reduced. So look at that. Okay. And I don't know if we do a similar one, if we'll get anything more interesting. Let's go ahead and try to get a similar question. At least they're not yelling at me about similar questions. Take a quick picture of this. Well, let's do it. I'll just do a new sheet. Okay, so 1/4 times 2/4. That's going to be equal to 2/16, which is equal to 1/8, right? If we take out 2. Oops, sorry. So 1/4 times 2/4. 1 times 2 is 2. 4 times 4 is 16. And then we can divide both of these by 2, and we get 1/8. So we end up with a unit fraction. And then the other one, I've got too many things going on here. We've got 1/6 times 3/4. And that's 1 times 3. We get 3. And then 6 times 4, 24. If you've been working on your multiplication table, you'll see 3 goes into 24 and into itself, giving us 1/8. So interestingly, both of these problems, they look very different on the surface, but they yield the same answer. One gave 3/24, which reduces down to 1/8, and the other gave 2/16, which also reduces down to 1/8. So this is how you can get certain insights in math. When you reduce your fractions all the way down, you'll see similarities that you might not have noticed if you hadn't reduced. All right, go give those a try, and if you run into trouble, message me from inside the app, the WAMAP app.